Professor Wergeles here, going through the start method on our own custom visualizer. If I open up Visualizer 1, you'll see here I go ahead and add the objects to the display. In Visualizer 2, you'll see I build a rectangle. That way the objects, if they go out of bounds, it won't be displayed. So let's look at the difference between Ellipse Visualizer 1 and Ellipse Visualizer 2. So you'll see on Ellipse Visualizer 1, at this time, I really don't have objects that can go out of the display. I have my y-axis increasing in value for the radius. So if I go to my update method, you'll see I'm setting the y radius based off my algorithm, but I'm not really going out of the display. But if I go to Visualizer 2, you'll see at this time, the visualizer could go out of the display because I'm rotating these ellipses in different ways than I did before. So at this time, the visualizer is going out of the display. So you'll see in Ellipse Visualizer 2, I set up a rectangle, which is essentially the height and width of the display, and make sure the objects are inside this rectangle. That way they don't conflict with anything else on the display. So if the objects move out of the display, I'm going to go ahead and cut and clip them off so they won't interact with other elements on the display. So for my visualizer, I'm going to do the same. So I'm going to create a rectangle. I'm going to call it my clip, and I'm going to pass the width and height of the display. Then I need to set where the clip is going to be located. So I'll call the clip, which is my rectangle. I'm going to set the layout X to 0 and the layout Y to 0. Now remember, this is not going to be 0 on the entire display. It's actually going to be 0, 0 on the anchor pane because that's going to be the root object. So you see here I say Viz pane, which is the anchor pane that holds my visualizer. I'm going to set clip with the clip that I created. So if we look at this set clip method, if I do a show Java doc, this is what you'll see. It sets the value of the property clip, specifies a node to use to define the clipping shape for this node. The clipping node is not a child of this node in the scene graph, rather is used to define a clip for this node. For example, you could use an image view node as a mask to represent the clip, or you could use one of the geometric shape nodes such as rectangle or circle, or you could use a text node to represent the clip. So essentially, if any parts of my visualizer go outside of this rectangle, then they're not going to be displayed on the page. Remember, this is a Java FX application, so I'm adding the import. You'll see I have 3 different ones. I have com.sun, java.awt, and I have javafx.scene. So I'm going to be using javafx, and the rectangle will be successfully imported. Now, based off this rectangle, I've already set my clip, so now I can start creating and setting ellipses on the display. So I came up with an algorithm. You'll see it in Ellipse Visualizer 1. Essentially, I grab the width of the display and I divide that by the number of bands. So I call that my bandwidth. And then I also have the band height. So I say, what's the height of the display? And I multiply that by my band height percentage. So you'll see band height percentage is 1.3. So based off these numbers, I create an ellipse array, and then I loop through and use these to set the center X and center Y as well as the radius. So you'll see as I'm looping through, I take the bandwidth, which is the total width divided by the number of bands. I divide that by 2, and then I increment it with the bandwidth multiplied by I. So essentially, it's going to start from the left, and it's going to start adding these ellipses moving horizontally to the right because I'm going to be multiplying it by I. Now that's going to be for the X. You'll see for the Y, they're all in the same spot. I basically place them in the middle of the display. And then I set default radiuses. So I set the radiuses for the X and for the Y, and I also set a default color. You'll see the start hue is a variable that I defined up here, which is 260. So that's going to be the default color. So when I open up the visualizer, you'll see here they're all defined as purple. And then I add them to the Viz pane. So that's what I'm going to do in my controller as well. So I'm going to call the bandwidth. We need to create this variable. It's going to be the width divided by the number of bands. So as I have more number of bands, I'll place them closer together. Then the band height will be the height of the display multiplied by my band height percentage. I have the half band height, which we'll use later, which is my band height divided by 2. And then I'm going to create an ellipse array and store all my ellipses into the array. So I need to create these variables up here. Now these are all UI variables and just not the default variables, which are right here. So here's our default variables that most visualizers will need to have. And here's the custom variables that will be very specific to your own visualizer. So you'll see I've defined my bandwidth starting at 0, 0, my band height starting at 0, 0, half band height percentage, which is 1.3, and my start hue, which is 260. And then I have an array for all the ellipses, and I'm going to have a for loop that's going to loop through and add all the ellipses to the ellipse array. So the variables are set up. Now I need to go and create the for loop, which is going to add them to the display. So I'll create a standard for loop with I equal to 0, I less than the number of bands, I plus plus. And then I'm going to create a local variable for ellipse. I'm going to store this into the ellipse array, so I don't need to worry about these ellipses being global. I'm just going to temporarily use them. So I'm going to create a new ellipse. I'm going to set the center X equal to the bandwidth divided by 2. So it's essentially the width divided by number of bands. So I'm going to make it even smaller, divided by 2, plus the bandwidth multiplied by I. So we can write this formula out. So if I is equal to 0, then the first ellipse will be all the way over to the left. So it would be the width divided by 2 plus the bandwidth. So let's say the width is 100 and the number of bands is 10. So my bandwidth will be 10. So it would be 10 divided by 2, which is 5 plus 10. So that would be where the first X position is. And then I'll say 10 divided by 2, which is 5 plus 10. So it'd be 15 plus 1 now, which will be 16. Then 17, then 18, then 19, then 20. And it'll keep going and add all the ellipses moving horizontally to the right. All the Y's will be the same spot, because I want them to be all in a single line. But maybe your visualizer, you don't want them to all be in the same spot. Maybe you want them to be in random positions. You can do that as well. Then I'm setting the radius for X and Y. You'll see I need a variable here called min ellipse radius. So I'll scroll up to the top and I'll make my min ellipse radius. Now we're setting it to 10. We talked about why we set it to 10 in the previous videos. If we get much smaller than 10, it doesn't look like a circle. And if we go below 10, go to 0 or negative value, the circle or the ellipse will not be present at all. So we decided that 10 was a good value for the default. And now I'm setting the color to the start hue, which is 260. I'm adding it to the viz pane and I'm adding it to my ellipses array. That way I can keep track of it later. So if I have my number of bands is equal to 2 ellipses will be created. If I have my number of bands equal to 140 ellipses will be created, and they'll all be stored to the ellipse array. You'll see the ellipse array is defined by how many number of bands there are. Now the start method's set up. The start method's a little bit harder than the end method, because the end method we're just going to go and delete all those objects. So essentially I'm going to check to see if the ellipses are null or not. If they're not null, so that means I have some ellipses, I'm going to loop through and I'm going to remove them from the viz pane. Okay, you'll notice up here I created a standard for loop because I needed I in order for me to increment the X position. So in this case I needed I. Here I'm using an iterator. I don't need any. I just want to loop through all of them and remove them from the viz pane. So I'm going through all the ellipses in the array and removing them from the viz pane. I'm going to set the array equal to null. So after I remove them from the display, I'm going to set the array to null so the garbage collection will come and destroy this object. I'm going to set the clip to null because we defined the clip up here as the rectangle. Maybe I don't need the clip in other displays, other visualizers. And I'm going to set the viz pane back to its initial style. So if it had initial style, I'm going to set it back to what it originally was. So now I have the start method defined, I have the end method defined, and I have get name. So I knocked 3 out of the 4 methods that I need to do. They're completed. Remember, the start method will always call the end method at the beginning to remove all the objects. We'll now move to the update method. Now the update method is where you're going to spend the most time. So the start method just adds the objects to the display by default. The end method removes all those objects. The update method is where all our algorithms are going to go. We're going to implement this in the next video. So stick with Professor Wergeles and we'll see you in the next video.